Hello, today we will learn about the real number system. The real number system is an important vocabulary. It consists of natural numbers, whole numbers, integers, rational numbers, and irrational numbers. We write the numbers in ascending order using braces to show a set. Set is a collection of objects or numbers. Sets are noted by using braces. Venn diagram is a diagram consisting of circles or squares to show relationships of a set of data. Now let's begin with natural numbers. Natural numbers are the set of counting numbers, so basically how you count. 1, 2, 3, 4, 5, and so on. If you notice behind the 3, you see those 3 dots or those 3 periods. That is what we use to represent to show that the numbers continue on infinitely. Whole numbers. Whole numbers are the set of numbers that include 0 plus a set of natural numbers. So a whole number can include the number 0. So 1, 2, 3, 4, 5, and so on. Integers. Integers are the set of whole numbers and their opposites. Includes all positive and negative whole numbers. So once again, if you notice to the left and to the right, you see those 3 dots. So all possible negative numbers that are whole numbers, and all positive numbers that are whole numbers. What are real numbers? Real numbers consist of all the rational and irrational numbers. The real number system has many subsets. For example, rational numbers, which has 3 subsets: natural numbers, whole numbers, and integers. And if you notice to the right, you see irrational numbers all alone. That's because it's in its own subset. What are rational numbers? Rational numbers are any numbers that can be expressed in the form of a over b, where a and b are integers and b cannot be 0. So for example, fractions, and of course integers, whole numbers, and natural numbers. Some other examples of rational numbers are fractions, both proper and improper, terminating decimals, or repeating decimals. So let's begin and let's talk about rational numbers that are terminating decimals. Terminating decimals are decimals that contain a finite number of digits. So a specific number of digits, like 36.8, 0.125, or 4.5. Rational numbers are repeating decimals. Repeating decimals are decimals that contain a infinite number of digits that repeat with a determined pattern. So for example, 0.3333. It repeats, but because it repeats in a determined pattern, it's considered a rational number. The second example is 7.689, because the pattern repeats in a determined pattern, then the decimal is a rational number. Now, you can also write these repeating decimals a little bit different. So I can write 0.333 by writing the 0, the decimal, the 3, and the 3, and putting a line over it. A line above the decimal indicates that the number repeats, so that 333 repeats. Here's another example, 0.666, and then the 3 dots, which basically states that the 6 repeats with a determined pattern, so it can also be written as 0.66 with a line on top. Rational numbers can also be fractions. What fractions or which fractions are considered rational? Fractions that are proper or improper, fractions that are negative or positive. So here are some examples of proper fractions: 1/2 or 1/2, 2 3/4, -5/7, -5 7/8, -9/11. Examples of improper fractions can be 10/3, 203/13, or -23/7. So as long as the fraction is positive, negative, proper, or improper, it's considered a rational number. Irrational numbers. Irrational numbers are any numbers that cannot be expressed as A over B. They are expressed as non-terminating, non-repeating decimals. Decimals that go on forever without repeating a pattern. So here are some examples of irrational numbers. The first example, if you notice, it's 0.34, 334, 3334, 33334. So even though it's repeating, it's not determined by a pattern, and it's not terminating, so it's irrational. The second example, 45.867458893, it's a non-repeating decimal. It doesn't terminate, so it's irrational. Pi is irrational because, as you guys all know, pi is an infinite number that never stops, never ends, and repeats in a non-determined pattern. Square roots that are not perfect squares are also considered irrational numbers. So the square root of 2 is not a perfect square. It's considered irrational. FYI, for your information, if you have not learned about square roots, when taking the square root of any number that is not a perfect square, the resulting decimal will be non-terminating and not repeating. Therefore, those numbers are always irrational. And some examples of square roots of non-perfect square: square root of 2, square root of 23, square root of 30, square root of 55. Here is an example of how a Venn diagram of the real number system looks. If you notice, there is a large rectangle. That large rectangle is split into two smaller rectangles or squares. To the left is rational numbers, which has 3 subsets, and then to the right is irrational numbers and has no subsets. So let's focus to the left. You see rational numbers, and then the next subset would be integers. And then the next one would be whole numbers. And then the most inner would be natural numbers. Okay, so here's some examples that I will be classifying as either natural, whole, integers, rational, or irrational numbers. Now let's start off with the number 117. The number 117 is considered a counting number, so therefore it's classified as a natural number. Because that subset is inside a whole number, then it's considered a whole number. Because the subset of whole numbers is inside the integers, then that's also considered an integer. And because the subset of integers is inside the rational number, then it's considered a rational number as well. So to summarize, the number 117 is a natural number, whole number, integer, and a rational number. Now let's look at the number 0. The number 0 is a whole number. It's not a natural number. And because the number 0 is a whole number, it's also considered an integer, and it's also considered a rational number. Now let's look at the number -3. The number -3 is considered an integer. Because it's considered an integer, then it falls into the rational number category as well. Now let's look at 6.36, and if you notice, it is in the rectangle or the subset of rational numbers, and that's because it's a decimal. So decimals, whether they're positive or negative, fall into the rational number as long as they are terminating or they repeat in a determined pattern. Now to the very far right, you see negative 12.64039 with those 3 dots behind. Those 3 dots indicate that it's repeating. It's not terminating, but because it does not repeat in a determined pattern, then it's irrational. Okay, so here are all the solutions that I talked about. Now, I did not discuss the negative 1/2, and that's a rational number only because it's a fraction. And I didn't discuss pi. Pi is an irrational number, but we had talked about that already. And 4/9 is a fraction, so it's considered a rational number. Now it's your turn to try it. You should have this worksheet. If you haven't printed it already, go ahead and print it. Once you have it, I want you to pause the video and classify those values. Determine what subset or what category they would fall in. And then once you are finished, come back, resume the video, and check your answers. Okay? Hopefully you are ready to check your answers. Let's see how you did. Okay. So I'm going to start off with the number 8. The number 8 is a natural number. We count 1, 2, 3, 4, 5, 6, 7, 8. So because that subset falls inside the whole number category, then it's also a whole number. It's also an integer, and it's also a rational number. So the number 8 is a natural number, whole number, integer, and a rational number. Now let's talk about the negative 5. The negative 5 falls in the integer subset, or circle. Now because the circle of integers is inside the rational square, then the number negative 5 is an integer and a rational number. Now let's talk about the square root of 9. The square root of 9 is a perfect square. 3 times 3 is 9. So when you take the square root of 9, it's positive or negative or plus or minus 3. So that falls under the integer category because the integer category is the category that can include positive or negative whole numbers. And it also falls under rational. So the square root of 9 is an integer and a rational number. Now let's look at 2/3, the fraction 2/3. Fractions fall under the rational category, and it's only rational. Let's look at negative 5 and 1/8. That's a fraction. Negative fractions fall under the rational category. Now let's look at 6.888, which is repeating, but it repeats in a determined pattern. So that's considered rational. Because it repeats in a determined pattern, it's rational, not irrational. And then let's look at the last one, negative 14.12. That's a decimal. Decimals that are positive or negative and terminate are considered rational numbers. So in this situation, we didn't have any irrational numbers. I hope you guys learned a lot, and I hope that you guys enjoyed learning about the real number system. If you have any questions, feel free to go back to a specific part of the video where you feel that you need to rewatch. Thanks for watching.